my Lab 9 video lab report on physics of extreme sports. So the main problem we have is we are given a video and we are supposed to track, model, and plot the motion of a mass swinging on an oscillating spring. And our main result is that we prove that our system obeys the energy principle, but we also learn that the period of oscillation for the x component of position differs from the period of oscillation from the y component. Okay, so this is a video that I tracked. And it gave me these coordinates, and I took them and I saved them in a CSV file, and I use this in my code so I can compare side by side what I've tracked to the model. And in my code I changed the ball mass to 0.402 kilograms. I changed the initial position to what my tracker gave me. I used G. I calculated a spring constant from the lab in LO. And I calculated delta E, gravitational potential energy, spring potential energy, and delta KE. And I plotted these all on a graph. This is how it runs. As you can see from my graph, the green is actually delta E, and that is supposed to be 0 because there's no work done on the system. Okay. So what does this mean? Compare the period of oscillation you found from examining the x component of position with the period of oscillation determined from the y component of position. Do they differ? And they do differ because gravity is acting in the y direction and not the x. And with your new choice of system, determine the work done by the surroundings. Is the energy principle satisfied? Yes, it is, because the work done by the surroundings is 0. There are no other forces acting on the system outside of gravity, the ball, and the spring. And the next question talks about changing the location of the origin and how does this change the physics of your system. And this change would make the delta E be 0, but it would change the potential energy and the gravitational energy because they depend on the stretch of the spring. And that is all.